Hello learners, welcome back to SOEM program. Today we are going to learn about database management system DBMS, its concept and types. So with this DBMS we are entering to the week 5. In the week 5 we are going to cover about a detailed lectures on database management systems. You know what is database? A database is a collection of related records, and a database management system means it is a software that enables users to create, manage and interact with the databases effectively. Databases store structured information such as membership records, journal records, books records, or any other customer details, records of issue and return of books, inventory data, etc. in a way that makes it easy to organize, retrieve and update. The primary functions of a DBMS include data storage, data retrieval, data security and data integrity. Through a DBMS, users can make queries, they can ask information from various databases, generate reports and perform complex operations without needing to know the details how data is physically stored. So let us see what are the areas which we are going to cover today. We will be having a brief introduction, historical development of DBMS, structure of DBMS, key features of DBMS, advantages, key features of DBMS, advantages and disadvantages of DBMS, classification of database management system, and we will be concluding this session last. If you say about introduction about the database management system, which we already discussed, DBMS is an electronic framework for efficient data storage, retrieval, modification and management. DBMS facilitates data-driven workflows and analysis. It also maintains relationships between data sets. It enables creation of databases, data storage, updates and table management. So these DBMS are essential in modern organizations because they streamline data management and reduce data redundancy and support multi-user environments. Some of the common examples of DBMS software include MySQL, Oracle, Microsoft SQL, etc. having used to across diverse fields for the complex data management system. By using a database management system, organization can ensure data consistency, data accuracy and It will improve the data security and make it easier for users to access and analyze the information. Overall, a DBMS plays a critical role in supporting decision making, enhancing productivity, and providing reliable information storage solution to all the organizations. So learners, one thing is clear, database management system is very essential for all the organizations, including libraries. If you go something deeper in the DBMS, one of the most significant aspects of DBMS is its adherence to the ACID properties, which are crucial for ensuring reliable transaction processing in databases. As defined by Jim Gray in the 1970s, ACID is an acronym that stands for atomicity, consistency, isolation, and durability. Atomicity is a property ensures that all transactions are treated as indivisible units. It guarantees either the entire transaction is completed or none of it is applied, preventing partial updates or inconsistent states. Another is consistency that ensures a transaction brings the database from one valid state to another one, maintaining database integrity and preventing it from being left in a half-finished state. The third component of ACID, that is isolation. Isolation ensures that transactions are executed independently on one another unit completion. This prevents intermediate results of one transaction from being visible to other unit it is finalized. And the durability guarantees that once a transaction is completed, the changes are permanent, even in the event of system failures. The database keeps track of all pending changes to ensure recovery after unexpected terminations. The implementation of the ACID properties allows database developers to focus on building robust system without needing to manually manage the characteristics of transactions, ensuring that data remains reliable and consistent. Yes, dear students, now we are going to discuss about the historical development of DBMS. The major development of DBMS, which is started during the period of 1960s, there was a development of general purpose DBMS developed during the 1960s. And Charles Bechman at General Electric, he created integrated data store, IDS. The IDS became the basis for the network data model. And IBM in late 1960s, they developed IBM Information Management System, IMS. And that was considered as a pioneer in the hierarchical database management model. And another development we can say that is a subarray system. The subarray system was jointly developed by American Airlines and IBM, International Business Machines, for airline reservations. And it enabled multiple users to access the same data over a network. And another important development we will find during the 1970s, that is a relational data model by Edgar Code. So, Edgar Code's contribution in the field of relational database, it was a great contribution to the database management system. He introduced the new data representation framework that leading to the relational data model. Learners, during 1980s, we will find the commercialization and standardization of relational database management system. That is a SQL standardization, ANSI 1986 and ISO 1987 that established SQL as a standard. During the 1990s, the developments we can see in the form of object-oriented and object-relational data management system. This object-oriented data management system support for complex data type and objects, and the object relational DBMS like PostgreSQL and others add object-oriented features to the relational database management system. During the period of 2000, we will find emergence of database like NoSQL and big data technologies. NoSQL database like MongoDB, Cassandra, etc. handle to the unstructured data. MapReduce and distributed databases like Google's MapReduce and Apache Hadoop process the big data. And 2010 we find another development, especially for the storage of databases. We found the cloud-based and new SQL databases during that period. In cloud databases like Amazon's RDS, Google Spanner, Azure SQL, database provide scalable services have been emerged. And as far as new SQL is concerned, they having the combines NoSQL scalability with RDBMS consistency. As far as new SQL is concerned, it combines NoSQL scalability with RDBMS. For example, the Cockroach DB and Google Spanner we will find in the form of a new SQL. During 2020s, there is emergence of hybrid and multi-model databases. Multi-model database like Arango database, Couchbase support multiple data models in one database. Artificial intelligence and machine learning integration also we found in the 2020s. DBMS use machine learning for performance optimization. Now let us see the structure of database management system. The database management system DBMS works by accepting SQL subject query language commands which are used to communicate with database from different user interface. These commands also be embedded in programming languages like Java and COBOL. When user sends a query, the DBMS process it using several steps. you will find when the query is being made by the users, then it will start out processing with relational operators. Okay, here we will be finding the processing, and they will be having the plan execution, operator, evaluator, optimizer, parser. Then they started the operating it with this all these relational operators. Then it will come to the file access methods, file access model. From there, it will go to the buffer manager, and it will be having the disk space manager. And all this having a concurrency and crash recovery using transaction manager, lock manager, and recovery manager. And finally, that system will give the uh, information after this processing, it will give to the users. So these are this is the architecture, we can say, of database management system. The next slide we are discussing about what are the advantages of database management system. The first advantage, we can say, it is a data independence. This database management system, which is having the independency in the data. Data have been stored in a systematic manner. The data has been stored in a systematic manner, and it can be retrieved independently from various databases. And it is having the efficient data access. This data which have been stored in the database management system can be retrieved, and it can be modified easily, quickly, and efficiently. The database management system enforces data consistency and the integrity of the data. Integrity constraints ensures that data is accurate and reliable, and helping prevent data corruption or redundancy. And the database management system also provides robust security features such as user authentication and access controls, ensuring that only authorized users can access or modify the data. This protects sensitive information and maintains data privacy. And data administration is very easy when you are having the structured database management system. And another advantage, we can see the concurrent access and crash discovery. Okay, whenever you need to access information, it is providing the concurrent access, and easily you can recover the data once the data has been lost. Then it will also reduce the developmental time. Okay, we using with the various systems and the technologies, we can easily develop a database. So automatically this database management system, which will be helping to save our time. Next is some disadvantages of database management system, like it is very complexity. Database management system are complex systems that require skilled personnel to install, configure, manage, and maintain. To handle the database management system, it is also need for a specialized staff such as database administrators or that automatically it will increase the operating cost. Performance overhead is another drawback. The DBMS can add overhead due to processes like transaction control, data integrity enforcement, and security checks. In case of a large data set or complex queries, this can lead to slower performance compared to simpler data storage methods. And the scalability is another disadvantage of database management system. It is refers to a system's ability to handle increased workload or growth in demand without compromising performance or efficiency. In this context of technology and databases, the scalability means as the amount of data or users or the processing requirements are increasing, the system will find difficulty to expand and to manage all this data. Another very important disadvantage is cost. It is a high cost. Implementing and maintaining a database management system can be very expensive. Its licensing fees, hardware cost, or ongoing maintenance expenses may require a significant investment, which can be will be a challenge for small business or libraries. Next is limited use cases, which refers to situations where a technology, tool, or system is suitable for only a specific set of tasks or environment, rather than being widely applicable across various scenarios. So, the databases which are prepared for a particular purpose or task, the database can be used for that particular task or that particular environment only. These are some disadvantages. Learners, now we are discussing on the classification of data management system. That means different types of data management system which have been grouped into different categories according to some criteria which have been applied. If you apply the criteria of the model which have been used, database management system can be grouped into different models, database models. The structure, the system which we are used to store and retrieve the data in the database management system. Say for example, the relational data model, it has been used in many current commercial data management systems. So, according to the database data model, we have different types of database management systems like hierarchical model, centralized databases, object-oriented data models, etc. So, this is a grouping of database management system or database management according to the data model. And number of users, based on the number of users using the databases simultaneously, we can group the database management system into two. One we are calling as a single user database management system, another is a multi-user database management system. The single user database management system, it will support only one user at a time. It is commonly used on personal computers. But in the case of multi-user database management system, it helps the multiple users concurrently. Okay, and according to the cost for developing a database management system is concerned, we can say some database management system we can develop with free of cost by using open source software. So, there are two types of again database management system according to the subscription or according to the cost. One is open source database, that is are free options like MySQL, PostgreSQL, often with third party support. We will be having the open source database management system. Another one is a commercial database management system like commercial relational database management systems. Okay, like trial versions and low cost, like trial versions and low cost personal versions are available, various commercial database management systems. So, let us say next is database according to the distribution of databases. If it is distributed in centralized way, we are calling as a centralized database management system. In this database and the DBMS are located in a single computer site. It is one's computer site will be there. From there, the people can access. It will support the multiple uses, but from a centralized location, only from one location. Another type of database, according to the distribution, we can say it's a distributed database management system, DBMS. This database and the DBMS software are distributed across multiple sites connected by a network. For example, homogeneous DBMS, same DBMS software at all sites. Homogeneous DBMS, it's a same database management system software at all users. And another type of distributed database management system is heterogeneous database management system. This is a different database management system software for each site. The first one, homogeneous, having the one software for all the site. Heterogeneous, having different database management system or software for each site. Federated database management system, or that we can say multi-database system, where the middleware software allows access to multiple autonomous databases. Database can be used different database management systems and retain local autonomy. This is something about the different types of database management system, and in detail in coming classes we will be covering in more detail about this different types of database management systems, including database management models. And learners, let us conclude. Database management system have revolutionized how data is stored, managed and retrieved across various domains and disciplines. DBMS provide an efficient and structured approach to handle large volume of data while ensuring the reliability, integrity and security of the data. By adhering to the ACID properties, database management system ensures that transactions are processed reliably, making them a cornerstone of modern computing. The historical development of database management system, from early hierarchical and network models to advanced relational and object-oriented systems, has fostered the improvements that a database management can practice. So, the database management system have transformed data handling, ensuring efficient storage, management and retrieval with reliability, integrity and security. With the various types of database management systems are available, such as relational, non-relational, centralized databases, organizations can select the system that best suits their needs, depending on factors like scalability, flexibility and data complexity. Despite challenges like performance overhead and complexity, the advantage of using a database management system such as data independence, improved data access and robust security make it an indispensable tool for managing the ever-growing amounts of data in today's digital world. So, thank you, dear students. We will be meeting with another topic in the next class. Okay, thank you very much. Once again, take care.